Welcome back to new session. This is your trainer and PMP coach Anand. This session is continuation of quality management knowledge area. In this session, you will learn control quality process. The learning objective of session are: we'll start with the overview to understand what is control quality and how often we can execute this process. We'll talk about process definition, input tool techniques and outputs. We'll talk about some of the key tools and techniques like inspection, testing and product evaluation. And we'll try to understand what is the output that is verified deliverables and where it will be used. And finally, a quick review. Let's quickly look at all the quality management processes. First one is plan quality management, which is part of planning process group. This is about creating a quality management plan. Next is manage quality, which is under executing process group, which we learned in a previous session. And finally, we have control quality under monitoring and controlling process group. This process is about executing quality activities like testing and inspection. You will learn about this process in the current session. Let's use the same example we used earlier to understand manage quality process. The construction company is building a tower where you purchased a flat. Project manager of construction company has developed the quality management plan and it's being followed by his team, including quality team. Now think about activities performed as a part of control quality process. Activities like checking quality of material used in construction like cement, iron, etc. Of course, there are many materials used. Every floor will go through inspection to ensure there are no cracks in the pillar and structure is built as per agreed requirement. Once the flat is built, inspection team will ensure walls are painted properly with agreed color, tiles are fixed correctly, cupboards are built according to the specification. So what are we doing? We are recording results of executing the quality management activities. And we are also ensuring that deliverables are correct and they meet the customer expectations. Once the construction is complete and flat is almost ready, it will go through final round of inspection. If everything is correct, then it will be marked as inspected deliverable. Most of the time, quality control team will mark each flat with a quality checked sticker at the entry door, and this is called as verified deliverables. Let's look at the definition. Control quality is a process of monitoring and recording results of executing the quality management activities to assess the performance and ensure outputs are complete, correct, and meet the customer expectations. The key benefit of this process is the project deliverable will meet the requirements specified by key stakeholder for final acceptance. Let's look at some of the commonly used terms. Prevention. It is about keeping errors out of the process. This is achieved through a proper quality planning. Inspection. This is about keeping errors out of the hands of the customer, which is achieved through control quality process. Attribute sampling. You have identified product attributes and quality matrices during quality planning. During control quality process, you will execute the scenarios and record the results. The results will either confirm or non-confirm. So attribute sampling is used in statistical samplings. It is similar to FTA, that is fault tree analysis. Variable sampling. Again, it is about sampling, but in this case, the result of variables are rated on continuous scale that measures the degree of conformity. For example, in software testing, defect might be classified as a low, medium, or high. So it's not yes or no, ya pass or fail, but they are classified on some sort of a scale. It is also used in statistical sampling. Tolerance. Tolerance is specified range of acceptable result. It is used in quality matrices. For example, performance matrix of each transaction in software system is agreed between say 1 to 5 seconds. So while testing, any transaction falls within this range is passed and rest are failed. So there is a set tolerance limit inside quality planning or quality management plan. Control limit. Control limit is about specifying boundaries for a stable process. This is used in process control and control charts. Let's take a look at ITTO. There are 7 inputs, 6 tools and techniques, and 6 outputs. So lots of ITTO in control quality process. Let's go through them one by one. So inputs are project management plan, project documents, approved change request, deliverables, work performance data, enterprise environmental factor, and organizational process assets. The component of overall project management plan that is an input to this process is quality management plan. So what we can use from quality management plan? The quality objectives of the project. Deliverables will be compared with the quality objectives to ensure deliverable fulfill these objectives. If a project has to implement certain quality standards, then those references can be found in a quality management plan. Roles and responsibilities. We will get to know who will conduct the quality control activities. It is done within the project team, by separate quality control team managed under organization's quality department, or by a separate entity itself. Which deliverables are subject to quality control? What level of quality control is applicable for various deliverables? The quality control management activities planned for the project, like how and who will monitor quality activities and how will it be controlled. Different industries uses various quality tools. So quality management plan will tell quality tool to be used on the project. Procedure for dealing with non-conformance, such as the defect repair process. So all this information will be made available to you through a quality management plan. Project documents. Lesson learned register. Lesson learned during quality control process early in the project can be applied to later phases to improve the quality control. Quality matrix. These are an output of planned quality management process. These are product attributes documented in the form of metrics. These are required to understand how control quality process will verify compliance with this metrics. Finally, test and evaluation documents. These were created in the managed quality process. They will be used to evaluate achievement of a quality objectives during control quality process. For example, in software project, these are simply called as test cases, which will be executed during quality control or control quality process. Approved change request. This is output of perform integrated change control process. Let's take a software project example to understand this. Software development team has developed a software and it is forwarded to testing team for a verification. So currently control quality work is in progress. In simple word, testing is in progress. Imagine final round of testing results in 20 defects which need to be fixed to proceed further. So there will be change request that occurs as an output of a current process to fix these 20 defects. These change requests are evaluated in perform integrated change control process, and once they are approved, then modification will be done on the project in the area of a quality control. In this case, it's a defect repair. So the implementation of this approved changes, in this case defect fixes, will be verified in the current process. Deliverables are the output of direct and managed project work process. Deliverables are inspected based upon the test and evaluation documents as per quality management plan. They will be inspected in two various areas. Inspected against scope to ensure completeness of the work and against quality requirement to ensure correctness of the work. Work performance data. Data on the product status such as observation, quality matrices, and measurement for technical performance are used in this process. This data will be compared to the quality standard to verify if the product conforms to the agreed standards or not. Enterprise environmental factor. Project management information system. It is a software used to manage the overall project, including various aspects of quality management. Generally, there is a confusion with project management information system as it also holds the historical data from the past project. So keep in mind, project management information system is a EF because this software is implemented at organization level and it is organization's asset. Mostly it is developed by external company and licensed to your current company in which you are executing the project. But the previous project data is stored inside PMIS and that will be considered as an organizational process asset. So I hope this clarifies the confusion of PMIS as EF or OPA. Well, what is OPA used over here? So OPAs can be quality standard and policies which are documented in the quality management plan, issues and defect reporting procedures and relevant stakeholder communication policies. So we talked about standard procedures and policies, and various quality templates like check sheets, checklist. So all these also can be used on the project. Tools and technique. Again, lots of tools and technique. To be precise, I think 6. Yeah. Data gathering, data analysis, inspection, testing and product evaluation, data representation, and meeting. Let's look into each in detail. Data gathering technique. Again, so many techniques are here. So we have checklist, check sheet, statistical sampling, questionnaire, and surveys. What is checklist? Checklist defines standard guidelines or standard operating procedure for quality control activities to ensure activities are performed in a uniform manner. The example on the screen shows the procedure testing checklist for IT system administrator. It has list of checkpoints. Each will be verified by IT system administrator and marked. This checklist will ensure that activities are executed in a same sequence by everyone and every time same sequence is repeated. Next is check sheets. Please remember there is a general confusion between checklist and check sheet. So for exam, it is very important to have a clarity on both. So check sheets are used to gather data on attributes and any defects that are found during testing. Check sheets can help pinpoint the source of a defect. The example on the screen shows motor assembly check sheet. In first column, each row is listing activities and subsequent columns it lists weekdays, that is from Sunday, Monday and so on. The number of lines represent number of defects found in respective activity on specific day. So you can see some places you have one line, some places you have multiple lines. So that is nothing but a number of defects. The last column shows the total defects per activity and last row shows the total defects found per day. So this is overall a check sheet. This is how it gets used. Overall, we can say check sheet can tell information about the defects. So information like the number of defects, the specific type of defect, and even the date the defect was occurred. Statistical sampling. It is not possible to inspect every material used in the project. For example, on construction project, is it possible to test strength of each bricks used? Not possible. So this is where you take a part of a population of those components which are produced as a result of a process which has been acquired from a vendor, whichever case, and the sample is inspected, are measured and compared to the quality matrix to verify the quality. The sampling frequency and the size of sample are agreed during the quality planning in quality management plan. Questionnaire and surveys. They can help gather data about customer satisfaction. This is generally done after the deployment of a product or service. There are two data analysis techniques used in control quality: performance reviews and root cause analysis. What is performance review? It is a measure of performance of a quality on the project. It is done by measuring, comparing, and analyzing any variances seen between the actual results and the quality matrix defined during the quality planning, of course in the quality management plan. Root cause analysis. Again, very generic tool and technique used in various other processes. Here, it is used to identify source of the defects. Inspection. It refers to the examination of product in order to determine whether it is according to the documented standards or documented requirements. It can be called as reviews, peer reviews, audits, or walkthroughs. Inspection can be a result of individual activity, so individual activity also can be inspected, or at the end of a product, it can be inspection of a final product of the project. In both cases, it results into quality control measurements. So these are the outputs of your inspection. Inspections are also used to validate defect repairs. Testing, product evaluation. This is an organized investigation conducted to provide objective information about the quality of product or service. Tests are done in accordance with the project's requirement. Intent of testing is to find errors, defects, bugs, or any other non-conformance in product or its component. Know that different application area has a different types of testing. For example, software testing, your construction company, your construction industry testing. In software testing, you might use unit testing, integration tests, black box, white box testing, interface testing, regression testing, alpha testing. In construction, you might use cement strength testing, concrete workability testing, non-destructive tests, or soil tests to design appropriate structure of the building. Remember, early testing helps identify non-conformance at the beginning of the project, and it helps reduce the cost of fixing non-conforming component of the product. Data representation tool and technique. There are various data representation techniques used during control quality process. These are cause and effect diagrams, control charts, histogram, scatter diagrams. Let's look into each one by one. Cause and effect diagrams. These are sometimes known as Fishbone diagrams or Ishikawa diagrams. They are used to identify the root cause of the problem. This kind of diagrams break down the potential causes of the problem statement into discrete branches. In quality, it can trace complaints about a quality problem. Let's take an example. In this diagram, the main problem identified is a poor quality product. So this is a problem that needs to be solved. Through the brainstorming with the team and SME, or with the help of 5 why technique, you can identify major causes. What is 5 why technique? It's a technique where you repeat question why 5 times to lead to the root cause of the quality or the problem. Further, Contributing causes are identified for each major cause. Control charts. These are used to determine whether a process is stable and has a predictable performance producing same outcome or not. Take a look at a picture. It illustrates results of a process over time, and it helps determine whether a process is in control or out of control. There are control limits and specification limits established during the planning. So what are these? Specification limits. There is upper specification limit and lower specification limit. These are the points determined by customer. Control limit. There are upper control limit and lower control limit. These are the points determined based on the requirement and mostly determined by a process owner. Lot of time they are referred as a 3 sigma limits. Sigma is another name for standard deviation and indicates how much variance from mean is permissible in the process. Level of quality is indicated by 3 or 6 sigma. 3 sigma means process is 99.73% accurate, means out of 1 million product produced, there may be problem with 66,807 products. 6 sigma means process is 99.999% accurate, means out of 1 million product produced, there may be problem with only 3.4 products. Accuracy percentage for 1 and 2 sigma are 68.27 and 95.44% respectively. Some of these numbers will be important for a calculation. You understand the purpose of control chart. Let's see how to draw it and analyze it. Let's take an example that you have a factory and you receive an order to manufacture 1 million screw with a length of 6 cm. Now while manufacturing this product, you also want to ensure process is in control. Now what you can see on the screen is a control chart. Length of the screw is plotted on the y-axis and product's quantity is plotted on the x-axis. Now in this case, since the screw length requirement is 6 cm, it becomes the mean or average. What you can see on the center, which is a red line, is called as a mean or average. You further discuss with the customer and you learn that these are general purpose screw and variations are allowed. And hence you agree with the customer the length of the screw can be something between 7.25 cm to 4.75 cm. So these will be considered as upper specification limit and lower specification limit. The process owner or in charge of manufacturing these products want to ensure the specification limits are met. So he set the stringent control limit, that is upper control limit as a 7 cm and lower control limit as a 5 cm. And this is also called as a 3 sigma. Please note that here I am not using any formula for calculation. This is only for understanding. I hope you understand various terms used in this chart. These are very important for exam. Let's continue with the same example to see how to plot the data points on control chart and analyze the outcome. During manufacturing process, as the products are getting produced, length is measured and plotted on the control chart. If you observe the chart, you can notice all data points are between upper control limit and lower control limit. This means process is in control. As you can see, this is happy scenario and production will proceed as planned. Imagine next day while observing data point plotted on the control chart, you notice some variation. There is one data point which is outside upper control limit. This is called as special cause, and this means process is out of control. Another observation is there are 7 consecutive data points on one side of the mean. This is called as rule of 7, and this also means process is out of control. Variation may be caused by difference in machines, worker overtime, poor quality raw material, etc. So once it is established that process is out of control, you will need to identify the root cause to take corrective actions to fix the process. Histograms. These are called as special bar charts. These are the graphical representation of numerical data. They can show number of defects per deliverable, ranking of a cause of a defect, the number of time each process is non-compliant. For example, the deliverables have been scatter diagrams. It is also called as scatter plot or correlation charts. It predicts how change in one variable will change another variable. Take a look at a graph. Scatter diagram shows if there is a relationship between two variables or not. In this case, all the data points are scattered. It means there is no relationship. Usually, first variable is independent and second is dependent on the first. Scatter diagrams are useful when one variable is easy to measure and other is not. With respect to quality, scatter diagram can demonstrate a relationship between process, environment or activity on one axis and quality defects on other axis. The line drawn on the graph is called as regression line. There are 3 types of correlation: no correlation, moderate correlation and strong correlation. If there is no relationship between two variables, there will be no visible pattern between the data points as shown in the diagram. So in this case, there is no correlation. Let's understand this through an example. You want to analyze the relationship between speed of vehicle and accidents. So let's observe this on, say, Dubai-Abu Dhabi highway. As shown in the graph on the slide, the y-axis shows number of accidents and x-axis shows speed of vehicle. In this case, we are analyzing speed limit between 140 km per hour to 160 km per hour. As you can see the pattern, as speed increases, accidents are increasing. And this is called as moderate correlation. So there is a moderate correlation between two data points. Let's look at another graph. In this case, we are analyzing speed limit between 160 km per hour to 180 km per hour. And observe the pattern, and you can see as speed increases, accidents are also increasing rapidly. This shows strong correlation, and both are positive correlations as there is an upward sloping pattern. If there is a downward sloping pattern, then there is a negative correlation. Let's take another example to understand negative correlation. Here we are analyzing relationship between cost of project resources and reducing project profit. As shown in the graph on the slide, the y-axis shows cost of project resources and x-axis shows reducing project profit. As cost of project resources increases, the project profit will decrease. If the resource cost is one of the factors, then correlation will be moderate as shown in the first graph. However, if there is only one factor, that is the cost of resources, then correlation will be strong. Meetings. The various quality control processes can be done separately by team members, but certain quality decisions require project team meetings to decide the outcome. Some of the meetings may include approved change request review. Approved change must be incorporated into quality control process. and it should be verified through testing or inspection to ensure it was implemented as approved. Once everyone agrees in the meeting, CR will be considered as completed. Another meeting type can be retrospective or lesson learned meetings. The project team should periodically hold a meeting to gather lesson learned on the project. In agile environment, it is called as retrospective meeting. The purpose of meeting is to find out what were the successful elements in the cycle of sprint, what element could be improved in future sprint, and what to add to organization process assets so that it can be used by other projects as well. The output of control quality process are quality control measurements, verified deliverables, change request, work performance information, project management plan update, and finally project document updates. Quality control measurements. These are the documented results of the activities done in control quality process. For example, when testing or inspection is done, you may get results like number of test cases executed, number of test cases passed or failed, number of open defects or closed defects. These results further act as input to manage quality process. Verified deliverables. The goal of control quality process is to determine the correctness of the deliverables. Correctness means whether deliverables conform to the stated requirement or not. If there is a non-conformance, there must be a change made to the deliverable. This will be done by raising a change request, which is the next output. If they are accepted, this means the verified deliverable become input to validate scope process for a formal business acceptance. Work performance information. The work performance data, which is an input to this process, is compared with the quality matrices to find variances. This will result in work performance information like fulfillment of a project's requirement, causes of rejection, recommendation for corrective actions, rework required, list of verified deliverables, status of quality matrix, need for a process adjustment. The work performance information like recommendations for corrective actions will lead to change request. Again, that's the next output. Change requests. Recommended changes may affect either any component of project management plan or project documents. We just learned that earlier outputs, that is quality control measurements, verified deliverables, and work performance information may lead to change request. And this happens if results are not within agreed thresholds. Change requests are processed through perform integrated change control process where they are analyzed and either approved or rejected. Project management plan updates. Approved change requests may result in updates to the component of project management plan, especially to the quality management plan. Project document updates. Project document that may get updated includes issue log. If a deliverable does not meet the quality requirement, this is documented as an issue. Lesson learned register. The lesson learned register is updated with information on the source of quality defects, as well as which approach worked well or which failed during the current process. Risk register. New risk identified during this process, especially causes of a quality variances, are recorded in the risk register as a new risk. If there are updates to any of the existing risks, that is also possible. Test and evaluation documents. These documents are prepared during the planned quality management process. For example, in software project, they are called as test cases. Imagine during testing, which is a current process, it is noticed that there are gaps in some of the test cases. So modification to these documents may be recommended to make sure future tests are more effective and covers all aspects of a product verification. Good job, you have completed control quality process, and with this quality management knowledge area is complete. Let's do the quick review about topic covered in this session. In overview, you learn about purpose of control quality process through an example. We gone through control quality definition, learned input tool techniques and output. We talked about inspection, control charts, regression diagrams. We talked about testing and product evaluation, which is a newly introduced tool and technique. You learn about what is quality control measurements, and finally what is verified deliverables. Don't get confused between verified deliverables and accepted deliverables. Verified deliverables are output of control quality process, and accepted deliverable is a business acceptance of deliverables done in validate scope process under scope management knowledge area. Always deliverable goes through control quality process before it passed down to validate scope process. I hope now you got a solid understanding of quality management concept and entire quality management processes. Keep learning, you are doing great, and see you in next session. Thank you.